Hi, welcome to Physics 1.4 on accelerated motion. Acceleration. Velocity is not always constant. We speed up, we slow down, the velocity changes. This is called acceleration. Average acceleration is what we will study in this class. If acceleration is constant, meaning the velocity changes at a regular rate, the acceleration can be calculated and it will be the average acceleration. You need your kinematics 1 through 3 in order to solve these problems. You also have 3 graphs. On an xt graph, this time this will actually be a curve. Your VT graph will be a sloped line, and your AT graph this time will be a flat line. The transitions between the graphs are absolutely vital. You need to know that the slope of an xt graph is the velocity. The slope of a VT graph is the acceleration. The area under the curve of a VT graph is the displacement, and the area under the curve of an AT graph is the change in velocity. So problem solving, again, we're going to start with tube charts. But remember, not all problems will have all variables. But again, you are looking for distance, time, velocity, and acceleration in every problem. In a master tube chart, we're going to look at the individual equations for distance, time, velocity, and acceleration. And we'll do the rewrites of the kinematics, and you can add those to your formula sheet. Example 1. A ball is pushed with an initial velocity of 4 meters per second. The ball rolls down the hill with a constant acceleration of 1.6 meters per second. The ball reaches the bottom of the hill in 8 seconds. What is the ball's velocity at the bottom of the hill? Notice that I'm given velocity in meters per second, and they tell me that V naught is 4. I'm given acceleration in meters per second of 1.6, and I'm given a time of 8 seconds. All of my units do match, so I do not have to do any conversions before I can solve the problem. Then, solving the problem using EWA, equation work, answer units. I need kinematic 1, V is equal to V naught plus AT. Plugging in the values that I know, V naught is 4, A is 1.6, and T is 8. Units do work, and the final velocity at the bottom of the hill should be 16.8 meters per second. Example 2 is what you're going to be doing next class. Given the velocity and time data below, what is the displacement of the object? Well, since you start with velocity time data, it's a good idea to graph that. So when we graph that velocity time data, we can find the displacement by finding the area under the curve created by the rectangle and the triangle. So based on the area of a rectangle and triangle, 1/2 base times the height and length times width, or 1/2 time times velocity or change in velocity plus velocity times time, you will end up with 144 meters. Now, if you do that same problem based on the equations, the equation of that line is 12 plus 4t. We'll use a default position of 0. The equation is kinematic 2. Plugging in the values that we know, where V naught is 12, A is 4, and time is given as 6 seconds, then we can find 144 meters to be the displacement. We are going to be doing more problems together in class. Thanks for watching.